I'm going to assume that number n is an odd number, of course, because all even numbers are composite except even number 2. So we are going to assume n is an odd number. I'm also going to assume that n is not power of some prime. Okay, n is not equal to power of some prime, p power e. Okay, the reason is that if indeed n is a power of some number, we can easily conclude n is composite, right? And there exists algorithm to test in polynomial time. Given a number n, can you write it as power of two other power like this? Okay. Now the question is, how many elements of Zn star are strong witnesses in the case that n is a composite number? Okay. It turned out that, which is we will prove, at least half of the elements, at least half. Okay, this part, let's call this part. Okay, these are all evidence or witness. Okay, for n being a composite. Okay, that's nice because if you have half of the Zn star that we can use as a witness to show that n is a composite, then with the high probability we can find one of the elements. Okay, so this is something we want to prove. At least half of the elements of Zn star can be used as a strong witness for our Miller-Rabin. That's what we wanted to prove. Okay, I'm going to show to you that we can create a set called bad. Okay, what does that bad means? Bad means set of all elements that are not strong witness for composite, right? That's the bad set. And I'm going to show to you that bad set size is at most half of the size of Zn star. Okay, this is something we will prove. Okay, not to prove this, we will proceed in multiple steps. We will construct another set called bad prime. Okay, and let me show to you like this. Assume this is half of Zn star. Okay, I'm going to show to you that bad is contained in another set called bad prime. Okay, I'm going to draw another set here. Okay, what is the difference between bad and bad prime? That will be clear in the next segment, but at this point assume I will be able to construct a bad prime as another set. Okay, which contains all the elements of bad. Okay, that's basically the subset. Okay, and I will also show to you that bad prime is not a full Zn star. It is a subset of Zn star. Okay, there are elements, for example, here that are not present in bad prime, right? Okay, so the proof will proceed as follows. I will be able to show to you bad is contained in bad prime. Okay, so proof is as follows. Bad is part of bad prime. Bad is part of bad prime that I will show. First of all, I have not even defined what bad prime is, but we do know what bad is, right? Bad is set of all elements that are not strong witnesses. Okay, we defined what a strong witness is earlier, so that's the same definition. Okay, bad is contained in bad prime. All right, and that's one thing we need to prove. And we also need to prove that bad prime is a subgroup of Zn star. Why is that helpful? If bad prime is a subgroup of Zn star, we know bad prime cannot have more than half of the elements of Zn star. Okay, so I will say group here. This is not a set, just regular set containment. It is subgroup. Okay, so this is subgroup containment. Bad contained in bad prime is the very first step. Bad prime contained in Zn star is the second step. The third step is to show bad prime, okay, is not the same as Zn star, meaning there are elements in Zn star that would not be present in bad prime. Okay, is not exactly equal to Zn star. Okay, so if you are able to prove all of these three things, then we have achieved the goal that the number of elements in bad cannot be more than half of the elements of the group Zn star.